Well, we were test fitting the liner for our 20,000 gallon water tank here.
20,000 gallons under the sea?
Yeah.
Something like that?
So this will hold all the waste heat coming off the generator and the heat from the wood boiler.
So some of the things, we've had some pictures earlier of like the pipe work and so forth. That goes with the pipe work under the parking lot, for instance. That goes with this project then?
Yeah.
Cool.
Yeah.
So wanted to get the thing stretched, as opposed to like, why not just fill it with water and let it roll?
Because there's a whole bunch of plumbing that has to get done inside. We're going to put, I think, like a dozen huge copper coils inside there.
Wow.
And that's how we actually get the heat out.
Mm-hmm.
Because the water that's in this tank is not the same water that's going to be going through the radiators in Cedar.
Okay, so sort of a heat exchanger kind of thing?
Yeah.
And perhaps, maybe you said, I don't know, but the heat that's going to be in the chamber is going to be roughly how hot?
I think probably like 180 degrees. I'm not exactly sure.
Wow.
But right up near 200 degrees.
Yeah.
Which is a lot of BTUs.
And long term, that should be able to heat. Will that provide both heat and hot water, or just one or the other?
It should be able to provide both.
Mm-hmm. So this is another phase of the project. So we just were working on the sort of the heat retention, or where the reservoir of the heat will be going. Mm-hmm. And now we're off with Lucas here, where in the room where all the heat is created, actually. So I know this looks a little bit different than what we would have had like the past winter or two here, but maybe Luca, maybe you can talk us through a little of the ins and outs here.
Sure. So what we have in here is the 200 kilowatt diesel generator that we use to power all of our snowmaking equipment, which we've been running for the last 2 years as just a conventional setup and blowing all the waste heat out the window, much like you would with a car engine. A very large percentage of the energy in your fuel either is lost to the radiator or out the exhaust, and only about a third of it actually becomes mechanical energy. So we're going to try to catch as much of that waste 2/3 as we can in this setup here. So we've taken off the radiator, the intercooler, a whole bunch of stuff, and we're piping our coolant, our exhaust, and our charge air coming off the turbocharger through assorted heat exchangers and heat recovery setups, with the goal of catching as much heat as we can, and then we'll pipe it underground through some insulated pipes over to that water tank.
Cool. At this point, I mean, obviously we, don't have any data on it, but roughly, so if we were saying only a third of it actually gets used, a third of our energy only usually gets used, and we're losing 2/3, what percentage will we gain? Have we calculated that for this setup?
I don't remember what the percentage is off the top of my head, but we're figuring 600 to as much as 750,000 BTUs an hour of heat out of this setup, which for reference is about 3 times what the wood boiler that Ethan mentioned will be producing.
Wow.
So that will also be coupled into the same system, so when we're not making snow, we load it up with wood we've cut here on the property and keep things nice and warm.